Good evening, everyone. Please take your seats as soon as possible, please, so we can get started. Thank you. Well, good evening and welcome to our spring fling for aviation safety here out of the Minden-Tahoe Airport, Carson Valley Inn gathering here. This has always been a great facility for us to come to. The refreshments are fantastic. They do a great job here, and I'd like to thank Carson Valley Inn for hosting us tonight. My name's Larry Cheek. I'm the safety program manager for the operations for the Reno Flight Standards District Office. And it's always my pleasure to stand in front of a group like this. And even tonight, if you didn't not aware of it, we're broadcasting on YouTube. And I believe that's being recorded, so if you have some questions, you can hear yourself speak on YouTube later on. Nevertheless, our technical advisor and implementer back there is Frank Minock from the Minden-Tahoe Airport. Frank, can you come up here for a minute, please? We just want people to see your face on YouTube as well. Yeah. Well, I want to shake Frank's hand and thank him so much for all the technical work that he does. Minden-Tahoe Airport has always been a pleasure for me to work with. They're so proactive for safety. And there's a lot of activities that go on at the Minden-Tahoe Airport, all different levels of aircraft, helicopters, balloons, gliders, you name it. And so, Frank, if you'll step over here on this side for a minute, please. I'd like to present to you a certificate of appreciation to the Minden-Tahoe Airport Management. Awesome. And I'll just read this out loud here if I can get it out of the thing. Here, hang on to it for a second. There we go. Yeah, see, I can see it a little bit better now with my glasses. Okay, for their consistent and dedicated support to the Reno FAA Safety Team mission of education, training, and outreach by providing facilities and technical help in conducting safety seminars to the general aviation public, both in person and through their YouTube channel. Signed by Acting Manager of the Reno FSDA, Richard A. Falcon. Awesome. Thank you, Frank.
Thank you so much.
Yeah. All right. Appreciate that. And now we got a great presentation for you tonight. We got an unbelievable special guest here with us that's going to talk to you here at the first. And, you know, she's been in this arena and this subject area for so long, she can actually make weather. So anyway, I'd like to introduce Don Johnson from the National Oceanic Atmospheric Association. Here you go, John.
Well, thank you so much, Larry. I know I've been working with Larry here for many years, air races and whatnot, and he's always been great to work with. But thank you so much for having me. Truth be told, this is the first time I've given a talk in over 2 years, thanks to the pandemic. So hopefully this all goes well still. As Frank alluded to, I have been working at the Reno office now for about 12 years. I've been with the National Weather Service for 18 years now. Time has flown. And no, I did not start in kindergarten. But I've been managing our aviation program basically the whole time I've been there. And I'm also co-chairing our IWAS, which is the Intermountain West Aviation Weather Safety Workshop this year. And I will be talking about that. I'm going to be giving a shameless plug at the end. So another workshop that you may be interested in attending. All right, so mountain meteorology. Why do we care? Good question, right? All right, how many of you care about mountain meteorology? Yes. If you care about the granite that surrounds us, you're going to care about the weather. So this is just a great example here watching this video. This is from TV Hill. And you can just watch the flow around these peaks and these valleys. And maybe I can get you to play that one more time if you don't mind. There we go. But you can just see how the flow changes, and you can see the clouds obscuring the terrain, clearing out, and the different directions. So you want to make sure you know what you're getting into when you're getting in that aircraft and you're dealing with the mountains, right? So that is why we care about mountain meteorology. So what concerns me? Well, my 3 kids, but other than that, aviation. We're here to talk about aviation, right? These are some charts that we have gotten from, I was able to find from the NTSB, but if you go ahead and look at the amount of aircraft accidents, and approximately 30% are weather related. And a lot of those are avoidable if people got proper briefs and made sure that they were prepared for the conditions. So we have a lot of weather around here. Not only do we just have the normal flow patterns with the terrain, but we also have to deal with heavy wet snow. I mean, if that was your Citation X, would you be a little bit upset? Yeah, that probably cost a little bit. And of course, thunderstorms. We get a lot of wind. I'm going to talk in length about wind because that is a huge problem. Smoke. Smoke season is a new thing around here, right? Not our favorite. We can get low stratus and clouds. We can get dust storms, as we've seen with thunderstorms coming across as well. So there are a lot of things that we need to look at when it comes to weather and aviation. So I'm going to kind of break it down by season here and talk about each season, what are things that you need to be concerned with. So in spring, changing precipitation types. We can get these warm, gorgeous days like we had today, and then what happens tomorrow? Yep. Cold, snowy, you never know. Of course, tomorrow, no, it's actually going to be even hotter. But next week, I don't know. When it gets to this time of year, unless we're going to get some precip out of the deal, I am done with the cold. So I'm not too pleased with next week. Pellet showers. Those are always fun. Thunderstorms. Of course, we can get winds. We'll be seeing that as we cool down next week. What we call bowling ball lows. Has anyone ever heard that terminology before? Okay, picture that low pressure system. It's nice closed circle. They drop out of the north like a bowling ball. Drop right on top of us. That can bring us wind, it can bring us pellet showers, it can bring us thunderstorms, it can bring dramatic temperature differences and rapidly changing conditions as well. I put that in spring, but realistically, anyone who's lived here long enough, you know that rapidly changing conditions can happen any time of the year. In summer, so this picture was actually, I think it was last summer, but that day, an hour earlier, skies were mostly clear. It's when why can't I think of the name of it? We had so many wildfires, I'm blanking on the name. The one fire that blew up it was from the south, but it was not Tamarack. No, that was Caldor. Thank you. But that thing blew up and we had things just flow right into the valley and it turned this eerie kind of brownish, grayish, reddish color. So of course we're dealing with smoke and fire impacts all the time now. The Zephyr wind. Everyone familiar with the wind flow patterns around here in the summer? Because they don't work the way mountain valley winds are supposed to work. Thunderstorms. You get wind, dust, hail, and of course, density, altitude can always be a concern as well. In the fall, yeah, we're still dealing with smoke now because that is our lives lately. I keep saying, can we get more precip this winter? That'd be great. Winds, we get a lot of wind storms. It could be south, southwest, or even the easterly directions. Thunderstorm potential. Transition seasons are notorious for being tricky. Reason being is a lot of times the models struggle to catch up with things. So especially the longer term forecasts when you're dealing in spring or in the fall, take it with a grain of salt. And if you're reading our discussions, you'll know why. And atmospheric rivers. We have seen our fair share of those, not as many as we would have liked though recently. And then in the winter, snow amounts and character, wet versus dry, flash freeze potential, fog, freezing fog, low stratus, the rain and snow lines and the transitions. I hate to say this, but guess what? With rain snow lines, we're not that good. Honestly, if we get within about 500 feet, I think it's fabulous. But what can 500 feet do? It can make a big difference, right? It can mean snow at lake level. It can mean snow down on the valley floor versus not. And on a good day, 500 feet is reasonable. we can sometimes see errors more than 1,000 feet. Temperature and winds can always be a concern. Atmospheric rivers, of course, still in the winter, and maybe a marshmallow man or two. And of course, wind. That is our 4-letter word around here. If you saw that picture looking out the window, would you think it's safe to fly? Soaring, people. Okay, I need show of hands. Who soars? Who's a glider pilot? Yes, you probably would like that. Now, if you are in a prop plane, what do you think? Probably not. Okay. Of course, you know that the wave action is going to be imparted by the terrain. We're going to go more into depth of that as we continue on. But you get all those rotors and gusty surface winds. And looking at these concerns out of NTSB, so, we were talking about how weather-related can be a huge number. But now out of that chunk of weather-related, almost half of them are wind. So this is why you have to be so careful with winds, especially around here with the terrain. This is actually a time lapse from our office from a high wind day. And this is looking south. If you're familiar with Reno, there's the GSR. There's the airport right there. What do you see right over the airport? Rotor clouds. I can't tell you how often we are forecasting for Reno and we have a screaming southwest wind aloft, and all of a sudden I'm getting reports of gusty east winds out of the airport. And the tower's calling you frantically saying, what's going on? And you just tell them there's a rotor. I think, did we skip one by any chance? No? Okay. Well, I must have thinking my slides were in a different order. Okay, so we have two different type of high wind scenarios. One of them is going to be downslope driven. That's where we get those mountain waves, but instead of propagating and staying trapped aloft, we actually have breaking wave action. So think about like a hydraulic jump. Same type of effect here. Most typically, we're going to be seeing that in the fall or the winter time. Usually, if this is occurring, we're getting more westerly winds, and it hits the wind-prone areas the hardest right along the eastern Sierra. Easily gusts 60 miles an hour or more. Some of those, like Washoe Valley, the Galena Creek Bridge, those areas will easily see 80, 90 mile an hour gusts. Dayton's another one that's going to get a lot of wind as well. Now, gradient driven is going to be a temperature or a pressure gradient. So that is where you have a large difference in pressure centers, so like low pressure coming in compared to high pressure, or a large temperature difference. Sometimes you can get downslope enhancement with it, but generally it's going to be more widespread, sustained winds. So the downslope, you tend to get more stronger gusts. There's a larger speed gust spread, whereas gradient driven, it tends to be stronger sustained, and the gust spread is smaller. And once again, you're seeing gusts 60 mile an hour plus during the high wind events, but you're not just seeing it along the Sierra front, you're seeing it across the entire area. So that's the one I thought came afterwards. Okay, so that high wind day that I showed you. This is some of the quotes. We were listening to the ATC chat. Asking the UPS plane, how was it? We don't know where to begin. An unknown airline, get me the hell out of here. And this gem of a pileup that was over Mammoth, having a big jolt of turbulence causing the skin of the plane to wrinkle. Not good. So trap mountain waves is when we do not have the winds necessarily surfacing. That's where we start to see that flow going across the mountains. And obviously it can't flow through the mountains, so it's got to go up and over, right? And depending on the stability of the atmosphere, that can actually trap the wave. And you can see these wavelengths propagating for hundreds of miles. Obviously, you're going to have a lot of clear air turbulence with that. Sometimes you'll be able to see the waves. You're going to see lenticular clouds. You're going to see the rotors. You'll be able to actually, on satellite, it will look like this, where you have that series of wave propagating across. Guess what, though? If there's not moisture, doesn't mean the wave's not there. It can still be there. So the flow underneath is going to be the most dangerous for aviators. Obviously, we do have our soaring friends who like these waves, but for many, it gets a little dangerous. And then we also have the example of the Kelvin-Helmholtz waves there, which is kind of like a ocean flow where you have airflow in opposite directions, and it just causes these little wave crests. They're not as common. You're not going to see that too often, but when you do, it's kind of a treat. But it's, again, one of those situations where you're talking about some pretty rough air. So formation of mountain waves. As we were saying, we have our mountain range. We have a wonderful north to south oriented range, little mountains called the Sierra Nevada. And as that flow comes across, it starts to oscillate. And if it traps it because you have stable air both at and below the ridge level, then those waves stay trapped and can propagate across. Now you need wind speeds at least in the order of 15 to 20 knots. And raise your hand, do you think that happens frequently around here? Just a bit. Just a little bit. And you need the wind direction to be within 30 degrees of perpendicular to the terrain feature itself, which is why if we have stronger southerly winds, we do not tend to see as much mountain wave. So I remember talking about that in the forecast discussion, I want to say a week or two ago. We had an event, but we were not seeing as much mountain wave action because we had strong southerly flow as opposed to southwest to west. Obviously, severe turbulence can be a problem, and you have really strong vertical currents as well. You can sometimes pick up 2,000 feet a minute or more, and I think probably my soaring fans out there can attest to that, which is probably a good thing for them, but not so good if you're in a powered aircraft. So this is a great view. This was actually April 4th, so that was Monday? We were talking about those beautiful stacked lenticulars that we could see on Monday. So that was a view from space. This is the GOES 17 satellite. You can pick this up online. If you are curious about where, you are welcome to email me and I can send you all kinds of links. And I'd be happy to do that. But this is just a visible image looking across, and you could see all the wave action that we had going on that day. I think if you keep going. This is from a few years back, but still using the GOES 17 satellite. These are water vapor imagery, so you can actually see where you have descending air and it's showing the drying out. So the upward portion of the wave is showing up in the first image, it's in the blues, and the drier air with the sinking motion is in the yellows. And you can kind of see how that goes at different levels when you're looking at water vapor. Now, just a fun little fact there. Anybody hear about the GOES 18 satellite that was just launched? A few? Maybe? Okay. That was ballpark, a month? 6 weeks? I feel like, again, with 3 kids right now and working full time, I feel like my sense of time is just completely warped, but I know it wasn't that long ago. So that is up in space. They are doing the checks on it right now, and hopefully that will be available for some viewing images. It will actually be replacing GOES West, which is currently GOES 17. So we will be having some amazing imagery out of that shortly. Now, if you are curious and wanting to know more about graphical turbulence, the Aviation Weather Center has some wonderful graphics that you're able to go to. You just go to www.aviationweather.gov and click on their graphical turbulence guide, and you're able to choose different levels. You're able to choose if you want to look at combined intensity, if you're looking at mountain wave turbulence, if you're looking at mechanical turbulence. There's a lot of information that you can gather from there. Now, this is a case study back from February of 2019. Anybody hear about this one? So this flight was, I want to say, going from Santa Ana to Seattle, and encountered severe to extreme turbulence over the Sierra. It actually caused the autopilots to kick off. The beverage carts hit the ceiling and then came crashing down. We had it's either 3 or 5, I can't remember. I want to say 5 people injured, 3 were sent to the hospital. But you can see that on the PIREPs there, the flight attendants were incapacitated. And something that was really kind of a clue that maybe it was dangerous is in this aviation discussion here. We have in here, wind in western Nevada could cause extensive delays to air traffic and periods of downright dangerous flying conditions with extreme turbulence, very strong low-level wind shear, and unpredictable near-surface rotors. If you were reading that, would you say, hey, it's a great day to fly? No. So, unfortunately, there were some injuries. I don't think anybody, it didn't lead to any deaths, thank goodness, and the plane didn't crash. They were able to get it down, emergency land down in Reno. But it's bad when you emergency land in Reno in the middle of a windstorm. Now, of course, we also can see wind shear. We were just talking about those rotors that we get over Reno, where we can see, or I shouldn't just say Reno, but in that one video we had it over Reno, but we can get rotors really through so many of the gaps along the Sierra. We were just talking about them before this all began. And when we have those mountain waves and we start to get the rotor turbulence, we can really see it at any of our airports along the Sierra front. So we're talking Reno, Carson, Minden, Mammoth, and probably eastward as well. And we have been trying to do better about making sure there are wind shear mentions in the TAF. How many of you take a look at TAFs before you go? Good, a fair share of you. I like it. How many of you also read the discussion? Oh, good. Yes. Educated audience. I love this. But essentially, we have some better modeling now that we're able to get a little bit better handle on wind shear. I did a wind shear study for Reno. I would have loved to extend it into other airports as well, but I was basing it off of PIREPs. And guess what? I don't get very many PIREPs from other airports. And so, as pilots, if you are able to submit those reports, we may be able to use the data and do some more wind shear studies as well to compare it to what's actually, what is occurring versus what we're seeing modeled. Because I think wind shear is such a huge problem and something that we need to learn more about. So in terms of wind shear, there are 2 types. One's going to be convective, which is thunderstorms. One's going to be non-convective, which is usually when you have those breaking waves, when you get the rotors. In the convective sense, they're generally short-lived. Radar is going to be our best tool for detection, but radar has its limitations, and we'll talk about some of that too. We do not put wind shear in the TAF for thunderstorms, but if you see a TS, you need to assume that there is shear present. Now, the non-convective, it can last for hours. I've seen cases where we're getting shear at airports and reports of it for 8 to 12 hours at a time. We have a lot of tools to be able to detect it now, which is great. And it's going to be in the TAF. So as far as thunderstorms, I'm sure everyone has seen downbursts take place before. If not, I'm going to show you a video in just a second. But essentially, that downdraft from the thunderstorm comes down. When you're coming in, you're dealing with the outflow, so you have an increasing headwind. You go past it, you're getting pushed downward. Then all of a sudden, you're getting this tailwind, and you miss your approach. This has led to many crashes at airport sites, and I think has actually led to a lot of improvements with radar on major airports as well. Now, this is a video from our friends down in Las Vegas. This is actually a downdraft from a thunderstorm. Yeah, have a nice day. That would ruin your day. Nice to look at, but you sure as heck did not want to be under that when that dropped out. I think he's got it. We had a request for one more time.
What's the time compression on
It's actually on the bottom there. So it's, I want to say about 5 minutes or so when it was slowed down. So some of those downdrafts, the air rushing out of the storm can reach 100 miles an hour. Right on down. Now, in terms of non-convective low-level wind shear, these are a few of the environments that can cause it outside of our, our breaking waves and our rotors. Mountain valley effects, lee side effects with the gap winds, cold, any kind of front coming through because you're getting a wind shift with that. And then also any kind of low-level jet streams, nocturnal inversions. Of course, we get all of those here. So we try to highlight that to the best of our ability in the discussions. Icing is another thing you are clearly going to want to worry about. Anytime air temps are below freezing, your aircraft is going to take longer to warm. So if it's sitting for a long period of time, keep in mind that even if there's no icing on your wings, if you're flying through anything that has clouds, you're able to get those droplets and have ice accumulate on your wings as well. Your greatest threat is going to be in that super cooled liquid stage. So when you get cold enough, it's not as bad. When you're in that in between where it's going from liquid to frozen, that is your greatest risk for accumulating ice. Now, the environments that you're going to have to worry about, tops of any kind of heavy cumulus, cumulonimbus clouds, any freezing rain or freezing drizzle, which we don't get a lot of around here, but it's always a good idea to keep that in mind. If we have any kind of a really strong weather producing system, sometimes our more large coverage type storms, if you get up into the frozen portion of that, especially in the fall and winter and early spring months. And then also the windward side and crest of the mountains, you have a lot of lift and condensation taking place right there, which is going to cause more ice to accumulate as well. So we do not forecast icing in our office, but you're able to get the reports out of the CWSUs, the Center Weather Service Units, and the Aviation Weather Center, once again, has a great graphical component where you can go in and check the forecast icing, any kind of icing reports and SIGMETs, and also where the freezing level is as well. Okay, so the Zephyr wind. Now, typically, we should be going down valley in that night and up valley, up mountain during the day. The Zephyr turns that on its head. So we actually get a downslope wind in the middle of the afternoon because out in the basin of Nevada, it gets really, really hot. Hot air is less dense, it rises, it actually causes a surface low pressure. Now, the air across the mountains on a whole is colder. Colder air is relatively more dense. Air likes to flow from high pressure to low pressure. So now you have a surface high over the mountains and a surface low out over the basin. And so that air starts flowing downhill. And it's almost like clockwork in the summer. Those are the approximate timings for some of our airports. Of course, South Lake tends to only see the lake breeze. They don't actually get influenced by the Zephyr itself. But that is one thing to keep in mind because you will be seeing upslope, 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 and then we will reach that point, and all of a sudden you start getting a downslope into the afternoon. And I know a lot of firefighters who come out here, they're taught fire weather, and I see agreement right there. This, again, flips it on its head, and if you're not familiar with what happens around here, it can cause a lot of problems for them as well. So density altitude in the summer is another concern that we have. That's where we get those big, baking, hot, high pressure right over the top of us. It's a nice sweltering 100 degrees. We're all just like, I don't know. I actually went to college in Arizona, so 100 doesn't seem that bad anymore. But I will admit, I haven't been there in a while, and I've kind of gotten a little bit more of a wimpy. Like 95 gets hot for me now. But if we continue on there, Frank. There we go. So density altitude is defined as pressure altitude corrected for non-standard temperature variations. And of course, pressure altitude is going to be that altitude indicated by the altimeter when you set it to standard pressure. So 29.92 inches of mercury or 1,013 millibars. Less dense air, which both the altitude and temperature is going to play a role with, is going to not give you the same amount of lift, as I'm sure you're well aware of, and you may not be able to take off safely during the day, or you may need to lower the amount of weight in your aircraft. So that is just always something that we need to consider. I think I was looking at Minden for an example, and a reasonable kind of worst case scenario, say it was about 100 degrees with a 55-degree dew point, would put the density altitude right around 8,600 feet or so. So a little bit different from what you'd be dealing with at standard. Other concern in the summer are going to be our thunderstorms. Now, the greatest threat of a thunderstorm outbreak is if we have that high over the Four Corners region, we have a low that's trying to come in off the coast, because around high pressure, we have that air rotating clockwise. Around low pressure, we have it rotating counterclockwise. That acts like a nice vacuum, and it just pulls up all the monsoonal moisture up to the north. Several years ago, we actually had a period where it set up like that for days on end, and it just dumped rain. I think we issued like 40 flash flood warnings in a week. But those are those scenarios where you're going to really have the most thunderstorms. Otherwise, we do tend to see them a little bit more isolated. Of course, the terrain is where you tend to see the buildups the most. And also along convergent boundaries. So where we have that zephyr, we actually end up converging the wind, because the wind started upslope, starts to go downslope, and you have a convergent front that propagates eastward as it goes along. Some visual clues. So if you're out in the morning and you see these, we call them alto cues, altocumulus castellanus. If you see that in the morning, you already know that the atmosphere is unstable and there's moisture present. Then midday, you might start to see those clouds building up a little bit more. That's another visual clue for you. And then by the time we get to here, stay away, it's too late. So let's talk about predictability. How many of you did some NCAA brackets this year? Raise your hand. Anyone? Just one. Okay. But predicting the future is hard. I can say that, in the 18 years I've been doing this, there have been a lot of improvements, and I think we are probably making forecasts now 3 to 5 days out with the same kind of accuracy that it used to be at like 1 or 2 days out. But there's limitations on everything. So all weather forecasts are wrong. I mean, even if it's pretty good, we're not going to get everything right. Where there's too many variables, there's too many unknowns. But some are useful, right? What we're saying now is when you're doing weather forecasts on a longer term, it's about being a good statistician. We have a lot of variables, we have a lot of probabilities that we're dealing with. And as we get into the near term, that's where it's being a good meteorologist. So predictability is going to be a function of what you are interested in. 7 to 14 days out, we can give you a pretty good idea of broad trends. Transition seasons, though, that's kind of where I'm kind of saying, let's go more in the 5 to 7 day range. But in the core of summer or winter, 7 to 14 days, we usually have a pretty good idea. Now, does everyone remember, we've only had like 2 stormy seasons this entire winter, right? Around the holidays in December. And we had that huge atmospheric river in October. We had signs of that. I would give you a good 10 to 14 days out that those events were going to occur. So broad trends, we could say, hey, the West Coast is looking wetter, or the West Coast looks like it might be getting warmer. When we get a little closer, 2 to 4 days, we can usually start to talk about more what kind of storm. Are we looking at more flooding? Are we looking at more snow? Are we looking at a blizzard? Are we looking at a high wind event? These sort of details start to become clearer to us. And then when you get 6 to 24 hours out, we actually have some very high resolution convective allowing models that give us a lot more detail. I'm not saying they're perfect, but they do give us a lot of detail. Most of these models, though, only go anywhere from 18 to about 48 hours out. So they can help us now with smaller scale, high impact features. So that might be like a rapid snow level, a squall line, lines of thunderstorms, inside sliders. How many of you have heard us use that terminology? That like strikes fear in our hearts. Whenever we talk to the road crews and we say inside slider, they're like, they don't like that. So our old way of predicting, and if anybody's been reading our discussions for a while, it used to be like, the GFS, the EC, this one's doing this one's doing that. Here's my gut, this is what I think is going to happen. Or this is why it would happen last time. But our new way is actually using a calibrated blend of models, which is going to give us more scenarios and probabilistic data. So if you hear us reference the NBM, it's the National Blend of Models. It is taking varying weights of available models based off of how far out we are from an actual event and giving us probabilistic data that we can analyze. Now we're trying to help people make more informed decisions using this data. We feel that it's probably going to be a little bit more responsible of us to say, you know what, we're seeing a 70% chance that we could get 6 inches of snow, but there's a 20% chance that we could get 12 inches, as opposed to just giving a one forecast, a singular deterministic forecast. Because reality is, it's a forecast. This is not deterministic. It's not one single thing that could happen. There's a range of possibilities, and usually that range shrinks as we get closer to the event. Example being, we have this system coming in early next week. Our range of wind data, at least when I was in the office 2 days ago, we had anything from 20-mile-an-hour winds up to 70-mile-an-hour winds. What are we going to do with that? I mean, from a deterministic forecast, if we give you a single number, does that give you what you need? No. So if we're able to mention chances of it being certain levels, it can at least give you a little bit more detail to work with and help you make a more informed decision. So just for a little haha, we had to say, you know, hey, spring? Maybe not. And of course, Steve Carell there, you know, 60 degrees and sunny, or maybe snow. And just, you guys can all read that, but I just wanted to have a little joke in there because that's how sometimes things work out. So in terms of predictability, the quote easy, we have a great observational network now, a lot of webcams. Actually, Minden has a nice webcam now too, which we really appreciate. Satellite data is wonderful. The new GOES satellites that are up there compared to what we had previously, I want you to kind of think of going from black and white television to high def 4K. Like it was that big of a difference for us. Wind climatology and diurnal patterns, we have a pretty good handle on what things typically do. And mountain waves to a degree. You know, we know oftentimes the environments that create mountain waves, but how much it's going to oscillate, the peaks, the strengths, some of that we still are working on. The humbling part is going to be fog and low stratus and the extent of that. I'm going to use an example from Truckee. If anyone has flown in and out of the Truckee airport, you know that airport fogs in pretty easily. Now, there was a night where everything looked like it was going to fog, and it didn't. The next night, it was drier. There was more wind. And I was like, okay, well, if it didn't fog last night, it's not going to fog tonight. It fogged. And I swear to you, when I go back and after the fact still cannot explain why something happened, it drives me crazy. But that is part of the job. The rain versus snow level. I know I alluded to that rain snow line and that 500 feet being pretty good for us. But again, there can be large variations. We can see wet bulb differences where it starts to snow and then it turns back to rain. We have seen times where cold air damming keeps valleys as snow and then it starts raining at higher elevations. And it never turns over in the valley until the winds finally kick in and warm us up. Smoke. I will go into more details, but anything smoke related has been so humbling. Radar coverage, thunderstorms. I can tell you on days that we have a favorable environment for thunderstorms, do you think I can tell you where the first storm's going to pop? No. It's the same thing like a boiling pot of water. If you set water on a stove to boil, you know that it will boil. But you can't tell me where that first bubble is going to go, right? Same exact idea. Rotors, we don't have a very good, and I can tell you again, the environment is favorable for rotors. Can I tell you when one will form and exactly when one will break? No. And then the extreme wind events. We do struggle with those, exactly how strong, where is it going to be the strongest? We have good ideas, again, with that downslope versus gradient and where we tend to see the most winds. We know our wind-prone locations, but we are still surprised. So as far as smoke predictability, anyone want to shout out some reasons why you think it would be hard to predict smoke? I'm hearing a couple mumbles. That is very good. Yes, fires can create their own winds and weather. We don't know how actively a fire is going to burn. We don't know if there's going to be a new fire starting. We don't know what may happen if like a thunderstorm forms that day and it pushes an outflow. It can push smoke into an area. It can take smoke out of an area. So there are so many different characteristics, and also as far as attack on the wildfire, we don't know how much they're able to put it out each day. So we have models that can model smoke, and they're decent. I mean, it's a lot better than what we could have done, say, 5 years ago, but they still have a lot of limitations to them. This is an example. This is the American fire in 2015. There was actually a thunderstorm outflow and it pushed the smoke straight into town. So that was us watching it from the office going, oh my gosh. So as far as radar challenges, does anyone know where our radar is located? Raise your hand if you do. No? Nobody? No takers? Okay. Virginia Peak. So our radar is up around 8,300 feet in elevation. So that means the lowest beam is at that elevation. As you go out, that radar beam is actually angled upward. So the farther out you go, we're not sampling the storms a lot of times, especially far at a distance and for lower elevations. So when we're closer in, we're going to see it. As you go out farther, a lot of times we can overshoot things, and during the winter, we may miss it entirely. This is kind of looking at the 10,000 foot level in the coverage. Note how our area, not so good. So if you're out over Tonopah, good luck. I will say we do have a lower elevation scan now than we used to, which has improved things. It's better off than it used to be, but we still do not have the best coverage down there. You get down towards like Mammoth, your radar beam is hitting around 18,000 feet. You're not seeing almost anything. You get down, you want to almost use Hanford's radar because at that point you can see it at more around 13,000, 14,000 feet. So just keep that in mind. You are not going to be seeing everything on radar. Oh, see there, I was talking about that right there. This is where you would, down in Mammoth and Hawthorne, we would see 19 to 28,000 feet. Use Hanford's radar, you're going to see it at a much lower elevation. So big radar gaps, that's what's happening on the ground. Again, see, this is why we love having our cameras versus what we're seeing. So in terms of winter hazards, how do we know? Are we going to get flooding? Are we going to get a blizzard? Or are we going to get wind? In this case, we have a nice atmospheric river, good jet stream, snow levels are high, everything's coming together, and we get a lot of rain. Show of hands, who was here for the 16-17 winter? It was like a career memory-making winter for us, if you've been here for any length of time. Now, if we go and see for you guys, it'd be on your right. That's more of a wind scenario where we don't have the precipitation coming across, but we have the jet stream, we have the atmospheric river. This is the case, though, where the flow is more southerly. Southerly flow does not come across the mountains. That's where you see everything bank up along the Sierra. We get a lot of moisture there and hardly anything on our side other than a lot of wind. And then we get to our heavy snow scenarios. So it almost looks the same, right? In all cases here, we've got the atmospheric river, we got a jet stream. The big difference, though, is snow levels and stability and wind direction. So this is the case where we have it all coming together, but in this case, we've got a lot of cold air at the surface, so we can get a lot of snow out of it. This is our super mega atmospheric river from October. Now, this one storm dropped 2.92 inches of rain in Reno in 2 days. By far set an October 2-day record. And I want to say it was like our third wettest 2-day period ever. Well, since we began keeping records in 1895 or 1893. There we go. Now, our entire winter, our entire water year the year before, we only had 3.1 inches. So we got almost the equivalent of the entire water year in 2 days. Granted, it was our third driest water year on record, but if you think about it, this one storm has contributed a third of all the liquid that fell down here this water year. It was huge. And I will say, leading into that, we're talking about the probabilistic scenarios. We were seeing some scenarios and we were discounting them, honestly, because we're like, it has never rained that much in October before. And sure enough, it happened. In terms of big snows, if we have a really cold low dropping in, a good source of moisture, good jet stream, westerly push, southwest to west push, we can get a lot of snow that comes across into the valley itself. And then we have our lesser predictable snows, the inside slider and the Tonopah low. Those are both going to be a little bit more difficult. Those are ones where we're probably going to want to see kind of the white of the eyes of the storm before they come in. But essentially the inside slider, it's something cold that drops out of the north. Most of the time, these are not particularly wet events. We tend to only get several inches out of them, although I will say there was an event back in 2010 that dropped 2 feet in a band about 50 miles wide. Almost nothing on either side. The front stalled out. It just dumped snow in one little area. I can tell you what, we did not have that forecast. We had snow. We didn't have that much. But these things tend to catch us off guard, and they tend to be actually the most dangerous for transportation as well. With the Tonopah low, you have a low that situates itself kind of near Tonopah, and you have that counterclockwise circulation banking up against the eastern Sierra. So we tend to actually do quite well, even up here, Carson Valley and into Minden as well, with those sort of events. Other hazards that we have less predictability for, cold air damming. Remember I was talking about when the cold air gets trapped and all of a sudden we're seeing snow down in the valleys and rain up in the mountains. That scenario. And lake effect, we know when the situation is favorable, but it doesn't always happen the way you think. Anybody saw what happened up it was mainly Spanish Springs actually, in kind of the north side of Reno. We had a lake effect event off of Pyramid, and that we were writing about it. We're like, okay, looks good for lake effect, looks good for lake effect. Didn't happen the entire day, and we're like, oh, okay, well, I guess it didn't happen. And then that night it got going, and it went all night long. I live actually out in Spanish Springs. We got, I want to say, 8 or 9 inches that night off of that band. It was rather impressive. And this is just some of the traffic fun you might have if you happen to be driving in these events, because guess what? What tends to cause more accidents, 0 to 2 inches of snow or 6 inches of snow? Yeah, you guys are all over it. So this particular event here, to go from South Reno up into the North Valleys, it was taking almost an hour and 40 minutes. Gridlocked, no thank you. So I know we have a lot of avid readers of the discussion, which I love. I would say that is going to be one of your best tools, because we can only put so much into a TAF. We can only put so much into the data you're getting, but this at least gives us a place to be able to talk about probabilities, talk about our confidence levels, talk about why we think something's going to happen. So I highly recommend reading that. And not just the aviation part, but also read the full forecast discussion. It might give you a little more insight even. Now TAFs, I know we had a lot of TAF users out there. Just to talk about some strengths and limitations of the TAF. The strengths, it's a clear, concise, most people are familiar with the coding because it's very similar to a METAR. It has local forecaster knowledge involved in it. It's commonly used. I mean, clearly almost everyone raised their hand. And it's great as a planning forecast. But we can't put any kind of confidence details in there. There's no way to talk about how much frozen precipitation may accumulate. It's localized, right? If it's not happening in that donut, it's not happening. Clearly, you're flying in more than just the donut. You want to be able to know what's going on around you. And we can portray trends, but the timing may be off, and that's where we can put more details into that discussion. Now, as far as surface observation networks, this has gone drastically improved. We have so many more surface observations, and a lot of the power companies are actually adding more and more because they have a rather vested interest in what's going on with the winds and the weather in those mountainous terrains and wildfires, if you've heard of a few things lately. And the other one, and I just use Slide Mountain as an example here, but if you are on our website, if you go to weather.gov/Reno, choose observations and then choose remote data. There's a whole network of mountaintop sensors, and also this surface observation is available under that observation dropdown as well. But you can get all kinds of data from our mountaintop sites. And on show of hands, how many of you use that Slide Mountain sensor? Quite a few. Now, Slide Mountain, just as a heads up, it is operated by the Desert Research Institute, and it is prone to icing up. So be very cautious if you're like, why doesn't it have any wind? The winds are howling over the mountains. It's frozen. Yeah, the ski areas, though, do have a lot of sensors on their mountaintops that have heated gauges so that they are able to keep it going through these events. Satellite and radar network observations, there's a number of ways you can get that. As I mentioned, satellite data is readily available online. The radar data you can find out there as well, but just really good things to kind of orient yourself with to see what weather patterns are happening. And then, of course, check with the Central Weather Service units. They are co-located in the 21 FAA air route traffic control centers. If you are flying in this general area, you're most likely dealing with Oakland or Salt Lake Center and going south, Los Angeles, north, Seattle. But they're going to be the ones that are issuing the center weather advisories and the meteorological impact statements. And they are the ones working directly with the FAA specialists to make sure that air traffic is flowing smoothly across the nation. Other people to give a good shout out to is the Aviation Weather Center, as I had mentioned them already. They are one of only 2 world area forecast centers in the world. And they do all the SIGMETs and AirMets. There are all those graphical tools that are available. They have upper air charts, aircraft reports. The flight path tool is an amazing tool. Other websites, of course, is like Windy, Ventusky, there you go. And they also have a standard briefing page, helicopter emergency unit as well. So I would really recommend www.aviationweather.gov. Wonderful site for a wealth of information. So some key takeaways here. Be prepared. Make sure that you know your risks. And if you have any doubts, just wait, right? It's always better to be late, to miss something, than to not make it. And make sure you have a trusted weather source. Probably not Ron Burgundy there. 1 inch to 2 feet of snow tonight. And as I mentioned, my shameless plug for the workshop that I'm putting together. It is a 2-day free workshop that will be held at the Desert Research Institute, which is basically across the street from our office, June 10th through 11th. And you can find all the data on the website there, including registration. Because of the site that we're in, we are limited to 80 people in person each day. The second day, Larry is going to be there and offering wings credit as well for pilots who attend the second day. The first day is geared more towards operational meteorology topics. The second day is a pilot and controller workshop. Again, completely free, and if you are unable to make it in person, then we also are offering virtual options. You can register for a virtual option as well. Again, just go to that website, weather.gov/reno/IWAS, or email me if you have any questions. And I will have an agenda shortly, by the way, because we are going through all the abstract submissions right now. And now you can ask a meteorologist almost anything. Lenticulars. No, those are your mountain waves. So you're actually seeing your wave crest, descending, cresting, and descending as it goes across. And all of my contact information is right on the bottom there. And if you can't see it, it's Dawn, DAWN .Johnson, JOHNSON at NOAA, NOAA.gov. And you're always welcome to ask me for a card too if you just want to get a card. That's easy. All right, right in the back there. Go ahead. Yes.
Does that mean it's not moving vertically? What exactly is stable or unstable air?
Yep, exactly that. Yes. Okay, so the question is, what is stable air? Stable air, I want you to kind of think of a parcel. If a parcel is stable, if you try to move it up or down, it's going to want to go back to rest where it started. If it's an unstable parcel, if you move that parcel of air, it's going to keep moving. So an example being, let's say that we're heating up air at the surface. It's going to be less dense than the surrounding air. That's now unstable because it's more buoyant, right? It's going to want to rise. So that rising air is unstable. Stable air is in a situation like an inversion, where you have actually air sinking at the surface and it's stuck, trapped at the surface and not going anywhere. It's not moving. Does that answer the question okay? You're welcome. Others? Yes, sir.
So this may be just my own observation, but it seems like today's weather forecasting with all the information available is not as accurate as it used to be 10, 20 years ago. What's going on with that if that's what everybody else might feel as well?
So first I have to ask, where are you getting your data?
The radio station, the TV weather person.
So depending on where you're getting the data, some of it is straight model data and not human intervention. Around here, because of all the terrain, the models do not resolve the features to the degree necessary. So example, some of the models are on a grid that would be, say, a 12 to 15 kilometer grid. Now, our terrain changes much more rapidly than that. So what we're trying to do locally is add more of a local touch to it. Check out weather.gov/Reno. See if you're still getting that. But I do hear that. I get a lot of times people are telling me, my app is telling me this and you guys are wrong. And I'm like, well, we don't have an app. So I know it's not us. But we actually are trying to deal with things on a smaller scale with more local knowledge. So you're welcome to check it out and get back to me and see if it helps at all. All right. Okay, black right there.
Why doesn't AWAS seem to be able to pick up smoke? I was flying at 11,000 feet and right over there. It says clear below 12,000 feet. And I'm solid.
Now, AWAS is going to be AWAS or an ASOS if it does not have a human interacting. Because if you have an observer there, they can tell you what layers of smoke's at. It's looking straight up. And it's looking for any kind of obstruction that it's hitting. The smoke, unless it is thick enough to cause a ceiling, like a true ceiling, it oftentimes will not pick up on it, just because of how the instrumentation works. That's where, again, if you look at the satellite data, you'll be able to get a much broader scale perspective of what's actually happening. But yeah, it's just part of the built-in algorithms with the system itself and its limitations on there. But both like Truckee and Reno have human observers that are augmenting the METARs themselves. Okay, right there, and then I'll go back.
And where did all that smoke and haze come from the southwest yesterday afternoon? Came in almost like a front.
Considering I have no idea what you're talking about because I wasn't at the office, I couldn't tell you. I apologize. The TAF, there is a TAF at Carson. Yeah, we issue a TAF 4 times a day for Carson. It is in the soaring. No, because we have both Carson and Minden in the soaring, or we Oh, we don't have Carson there anymore? Okay. I will make note of that and get it back for you. In terms of the whatever happened yesterday, I honestly don't know. I was in meetings all day and not in the office, and I personally couldn't even tell you. Okay, so we just have Reno and Minden at the soaring, and you'd like the Carson in there. We can make that fix. That's an easy fix. I know, yes. I will agree with you on that one. Go ahead.
Briefly on the inside slider, the reason I ask, I've heard so many conflicting discussions about the inside slider that none of them really make sense until maybe today. Just briefly, is it driven by the jet stream when it comes down?
Yes. Okay, so the question is describing an inside slider. Now, we consider an inside slider a system that comes in from the north and drops down on the eastern side of the Sierra. So, Bay Area stays out of it. A lot of times the west side of the Sierra stays out of it. What tends to happen in those situations is the jet drops from the north towards the south and carves out a trough on the eastern side of the mountains. And so we get the low itself, because they'll kind of figure the jet's coming around the base of that trough and the base of the low, comes right in over us. With those inside sliders, we tend to see more snow in western Nevada and sometimes on the eastern Sierra slopes. Western Sierra might get nothing out of it. Bay Area, Sacramento Valley, nothing as well. But those tend to be much colder because they originate over land, usually Canada. And they don't tend to have as much moisture associated with them either, because they are not taking an overwater trajectory, they're taking an overland trajectory. So a lot of times the only way that we're squeezing moisture out of them is through frontal dynamics. It's the lift along the cold front itself. Does that answer the question? Awesome. Okay, go ahead.
I was wondering, it's been a while since I had a meteorology class, but
So we tend to look for icing taking place between -10 and -20 degrees Celsius, because that's going to be your hail growth zone, and we're going to be able to get that spark and that charge coming through. All right, one last one. Go ahead. Yeah.
On your graphic there with the zephyr winds where they're coming down,
Mm-hmm.
going back to my fire weather, obviously, but your typical fern wind, where it comes off the plains and drops, the compression is very significant.
Yes.
On the zephyrs, is there much compression, heating and drying, or not?
Not as much as with a fern wind. We will see actually a lot of times cooling taking place because it's taking that colder air from the Sierra and bringing it down into the valley. So it's a slightly different mechanism. Where we will see that compressional heating is in the downslope events where we're getting the winds coming and crashing down, but it's being forced over the mountain and the terrain. So it's not as much of a thermal difference that's causing it, but it's more the jet stream that's causing it in that case. And also easterly winds when we get an easterly jet and we're getting downsloping on the west side. All right. Any last ones? I think Larry needs me to wrap it up here. One more? Okay.
Plug to what you were talking about on the NOA and aviationweather.gov. I found, I was talking about that, and I found that to be really accurate.
Fabulous.
Great information in it, and I found it to be very accurate.
So just so we all heard that, we're getting a plug for aviationweather.gov. They're over in Kansas City. They do a great job. All right, again, thank you guys so much for having me. I really appreciate it and hope it's helpful.
Oh, thank you, Don. And Don, I can tell you, it won't be 2 years before we call upon you again. That's for sure. That's a fantastic presentation. So, got a couple more events planned here for the night: mountain flying and then special use airspace. In between those, we're going to surprise you with another event. So I want you to take 5 to 7 minutes now, just get some more coffee, water, take a restroom break or whatever, but please come back within 7 minutes maximum. Thank you. All right. Our next subject is going to be mountain flying and the many aspects of safety involved with that. And our presenter is going to be Rick McBurnett. He's a local pilot here, still very active in flight instruction here at the Minden and Carson airports. So, Rick, if you'll come on up, please. Here you go, man.
Probably when you get old, you need reading glasses when you get old. Anyway, just a little editorial comment to start here. This presentation is not about those that want to go hang their airplane in the prop at 1.15 times VSO and put them on really short one-way mountain strips. This is about the normal guys flying in these mountains. And Larry will tell you, most of our accidents here are at runways with plenty of length. So it's not that business of trying to be the hero. Also, you'll find throughout my presentation, I'll be talking about margin. How much margin do you have? In my previous life, I owned an aerospace engineering company, and we designed aircraft components. And aircraft components are designed with huge margins. We look at the biggest possible load and the weakest possible material, and then we add 50%. So remember that 50%, because we're going to talk about that. Also, there is no mission. There is no mission. That means if that doesn't look good, don't go. You don't have to go. And my final point is ego kills. Now, how can I say that? One of the guys we're going to talk about tonight is Sparky Emerson. He wrote the Mountain Flying Bible. That is the late Sparky Emerson. He spent a lot of time talking about flying up canyons and how to get out of them, and he did one time, and he crashed. But he wasn't happy, so he did it again and killed himself. Another good example is Steve Fawcett, the world's greatest pilot, right? Went out flying in the mountains, didn't check the weather, went up in a canyon, got caught in downdrafts, and they found him, a year later? So, ego is a killer, and I see that all the time when I teach flying. So you're going to go flying in the mountains, you got to do what things. You got to know what the weather is, and we just got a fantastic weather briefing. My God, I was highly impressed. You got to look at your aircraft, the performance of that aircraft in the environment, what route you're going to fly, okay, and what happens if it doesn't go quite as well after you land or before you land. Let's go through a couple there, Frank. This is for the people on the internet. There's going to be a question in the end, so you can get your wings credit. Frank, next. We just had a great weather presentation, and we're going to talk about mountain flying planning and how you get in trouble here. Next one, Frank. So these are our mountains, huh? Beautiful, beautiful. What don't you really see in these? I don't really see the wind. And as you find out, if you've flown around here like a lot of years like I have, wind is one of our major problems. Obviously, wind and density altitude, we'll talk about both of them. So when you do that weather briefing, and like I said again, that was fantastic, what are you looking for when you decide to go flying in the mountains? What are the key things that you want? How about the winds aloft at 9,000? Am I doing something wrong?
I just want to emphasize to the YouTube participants tonight that that slide that you just saw that we quickly went through has my email address, larry.d.cheek@faa.gov. Throughout the next two presentations, you're going to see 3 questions pop up during the presentations. Make note of the question and the answer. To get wings credit, you have to email me those 3 answers. Then I can give you wings credit. That's just to validate that you stayed with us throughout the whole presentation tonight. Thank you.
So, what are you looking for in that weather? These are items, and whether you read a FAA presentation, Sparky Emerson, any of these mountain flying presentations, that number 1 is really key. Winds aloft forecast at 9,000 to 12,000, 25 knots, and you want a lot of ceiling, right? Why is 2,000 feet interesting? What are the minimum en route IFR altitudes in the mountains? How much terrain clearance do you get? Oh, isn't that a nice number? Okay. Visibility. As you well, especially instrument guys, visibility is the killer. Visibility is the killer. And when you're flying in these mountains, you want good visibility. If you don't have these things, you got to think about not going. You might want to rent a car, as it says there, right? Now, takeoff. Next one. Okay, I don't like I wanted to do this later, but we're going to do it right now, mountain wave. You got to understand what's happening with the winds, and the presentation you just saw talked about mountain wave. Next one. This is so pertinent for us. What do we have here? We have the Sierras, and we have Minden and Carson right over here. And that flow comes over those mountains and down. And the glider guys tell me they get 3,000 or 4,000 feet a minute downdrafts on those that lee side of that mountain, right? The other interesting thing, it does start going back up, and we're going to talk about evasive maneuvers later, okay? But always, we're going to come back to this, not to the picture, but remember how the winds are flowing. They're flowing over and down. Okay. I'm not talking into it well enough. Okay, got it. See? That's why the airlines threw me out when I was 60, you know? Okay, next one. All right. And I really shouldn't go through this the presentation before, but we see a lot of these around here. Alto cumulus standing lenticulars. They're beautiful, right? Okay, but this is what happens with that mountain wave, as she so brilliantly talked about. And we need to understand now these glider guys, I know those glider guys are a little different, right? They love this stuff. You know, they see a mountain wave, oh yeah, man. Anyway, next one, okay? What's the wind doing? And this is really important stuff. It's not just coming over those mountains. It's what happens in the valleys, because it could be totally different. And one thing that actually happened to me a number of years ago, I was flying from Burbank to Dallas. Strangely enough, American Airlines flies to Dallas. And they leveled us off at 9,000 feet on a departure out of Burbank. All of a sudden, the controller goes, American 2412, say your airspeed. Well, 250 knots. You're showing 340 knots over the ground. A couple minutes later, Southwest 2412, say your airspeed. 250 knots. There was a 90-knot tailwind down that valley. Dangerous stuff. Dangerous stuff. Okay, next one. Okay. This is for you YouTubers, right? This is one of your questions. If you're not going to get your wings credit unless and you guys should know this, right? Next one. Okay, our favorite, right? Density altitude. We all know that is what? Pressure altitude correction for non-standard temperature. Is this better, Larry? You're looking at me. Okay. So we need to know what density altitude is, right? It's important stuff. What happens? The air is less dense. Guess what? Less performance. Engine performs less, etc. Next one, Frank. Okay. All right. What happens to these engines when you get higher? These non-turbocharged engines. 3% less power for each 1,000 feet. Next one. Okay. Also, this is a real key one around this area, and one of the things I see violated. You want to lean that engine for the max power before you take off. And what power setting do you lean that max? What is it? Full power. Full power. You lean for the top RPM that you can get on a fixed pitch. And then I use my EGT to lean my constant speed propeller, my 182. You have to do it. You're not getting enough power out of it if you don't, because you got too much gas for the amount of air that you have. Next one. Okay. Now this is really important, and one of the things, if you read Sparky Emerson's, the late Sparky Emerson, as I like to say, okay, what airspeed do you fly? You always fly indicated airspeed because that's what the wing likes, right? But on the other hand, your ground speed is going to be higher because your true airspeed is going to be higher, right? But don't get confused with that. And what guys will see, they'll come in at a 6,000-foot airplane and they'll go, oh, I'm at 65 knots. It looks like I'm going faster, because you are going faster. But the wing needs the speed. Takeoff and landing distance are significantly increased. And this is a good one. And it's a double-edged sword down here, because we talk about it a little different. Lowering your weight really helps as far as climb performance, right? Takeoff distances. So you want to go as low a weight as prudently possible. I'll also tell you, I do a lot of mountain flying, a lot of bush flying in Alaska, fly up to Montana and Idaho. I like a lot of gas. So, somebody that tells me that I'm going to have 30 minutes of flying of gas in VFR, I don't know about you, but I got a whole different minimum in the mountains. Mine's an hour and a half, just so you know, okay? So it's a double-edged sword. You want to reduce the weight if you can, but it's a double-edged sword. Next one. Okay. Now, before we go on to the route, these slides don't touch one of my favorite subjects, which is takeoff distances, okay? Now, obviously, if you look at the charts in your POH, you will see charts for takeoff distances over 50-foot obstacles. What I'm going to try to get over to you today is takeoff distance is important, but what is more important is, can you climb after you take off, okay? So I got a couple little examples here, and what I always suggest is you calculate the takeoff distance from your manual, all right, and add 50%. Back to that 50% I started to talk about, right? And so here's some numbers. Say you're going off of Carson's, 5,000 feet, 40 degrees C. That's hot, guys. It's over 100 degrees, right? Turns out this 172M needs 2,960 feet, according to this manual, over a 50-foot obstacle. Really? What kind of airplane is that? That's that brand new airplane with that factory new engine, and everything is tight in the controls, right? So what do you want to do? There's that 50% again, right? So you add 50%, let's say it's 3,000, so 4,500 feet if you add 50%. How long's the runway at Carson? 6,000 feet. How long's the runway at Minden? 7,000 feet. How long's the runway 16 right at Reno? 11,000 feet. South Lake Tahoe, 9,000 feet. Do we have, according to the book, a problem take off over a 50-foot obstacle? Not according to the charts. But what happens when this 172 starts to climb? Okay, and here's some numbers. At 40 degrees, see, that's a hot day. And I always like to look at the worst case. That 172 in the brand new engine will climb at 335 feet per minute. Okay, at 10,000 feet with a lower temperature, it's down to 200 feet per minute. And if you look, and I'm a search and rescue guy up in Washoe County, and the CAP people, if you can't climb at 300 feet per minute, you better not be there. So understanding that climb rate, and you can put it in terms of climb gradient if you're an instrument guy, but that climb rate, being able to climb, is so important. And a lot of these accidents, the recent one we had down at South Lake Tahoe, the guy took off to the south, right, on a hot day, and an heavy, not overloaded, but very heavy 172, couldn't outclimb the crane. Hopefully he had a good insurance policy. The other thing, Sparky has a little rule. He says, Sparky Emerson, the late Sparky Emerson, he always says, if you haven't reached 71% of your takeoffs, if you haven't taken off in 71% of the runway, you're not going to make it. Well, I like to look at it a little different. I do a little more, being an engineer. Look at the ground roll and that takeover 50, and double it. So if in 172, I get calculated out here, that's about 1,600 maybe 2,000 feet. How far are the runway lights apart each other? 200? 200. And you also have signs left, right? So that's a good way to do it. If you're not making flying speed when you're past that 2,000 foot of runway, you're probably not going to make it. You're probably not going to make it. Okay. En route, right? Now, route selection is key. And I see a lot of people say, oh, yeah, I'm going to fly down to Sacramento. I'll just fly over Interstate 80. Yeah, is there a lot of good places to land on Interstate 80? Not unless you want to die young. And my favorite one is in the winter. Oh, I can fly over. I can land at, I got that 5,000 foot runway at where? Blue Canyon. You better have your skis on your airplane. They do not plow that runway, okay? Now, the other thing is, remember that 2,000 feet again? We like that, right? And so many times we may want to go east to get that before we go west, right? Don't take off and head out. We had a guy a number of years ago. I know the guy. He's a retired my airline pilot. He decided to take off in his 172 and fly off that draw over towards Spooner Lake. There's a draw right there, right up there. And he had a 182, which is a damn good mountain airplane. He got in that thing, and the winds were howling that day. They were 30 knots at 9,000 feet. I canceled my instrument students that day. Guess what happened? He got caught in that canyon up there. He couldn't do it. The only smart thing he did is he kept it under control till it was on the ground. Crashed the airplane. Everybody walked away. Hadn't checked the weather. Didn't understand that mountain wave and how that wind comes over those mountains and down hard. And I guess he got a new airplane out of it. I hate these reading glasses. Okay, the other thing is analyze your route. And the great example I have here is, and you guys all know, when you cross a ridge, how should you cross it? Straight across or 45-degree angle? Right. And a perfect example, if you're coming out of Minden and you're going to South Lake Tahoe, it's really a good example of how you can do it very safely. You take off out of here and you go up toward Kingsbury, right? It's about 7,300. You get up to 10,000, right? You fly at 90 degrees or 45 degrees across, and my goodness, if that downdraft comes, you peel right back off and go down into the valley. And what happens when that wind goes down? It goes down, but it comes back up, right? So what speed do you want to hold if you get in that downdraft? Best rate of climb? No. And the CAP stuff that you can look at in that other information that Larry put will tell you exactly what to do, and I agree with it. Go to your maneuvering speed, and they did a whole analysis. You would actually get out of that downdraft faster if you don't try to sit there at the best rate or best angle of climb. Turn around, go down to speed up to maneuvering speed, and you can get out, right? Let's see. Also, a great presentation about those mountain winds, right? Every afternoon in the summer, big winds, right? And also, the wind velocities at the AWASs in Reno may not be right. We used to have a joke coming in the airliner in Reno. It'd say, winds calm out of the west at 25, because that wasn't a joke. It was absolutely true, okay? All right. Also, next one, I think we got a picture of some passes. No, let's go to the next one there. Okay, when do pilots get in trouble? Oh, a lot of times. When they get in the airplane, right? No, they get in trouble when they go when they shouldn't go, okay? Next one. Okay. Pressing the weather is really a killer in the mountains. I fly up to Montana a lot of time, and I always have that extra gas, and a lot of times those thunderstorms build in the afternoon. Many a time. In fact, I was with my sweetheart. We were going in there, and I'm saying, it started to come down. It was getting bad, and I said, I teach this stuff. And I teach to turn around and go and land and wait. So she says, well, what are you going to do? I said, well, I'm going to turn around and go down and wait. And it worked out. Okay, next one. Up. Question for the YouTubers, right? When you're looking in the mountains, what's the most critical thing you'll look for? Weather. What's that weather going to do, right? What's that weather going to do? Next one. Okay, landing. And I want to talk, not extensively, but about landing. One of the important things to understand when you're going, this is one of those Idaho airports, relatively long runway to speaking. It looks like it's hard surface, right? We teach now in little airplanes what we always did in the airlines, and that's what? What kind of an approach do you fly? Power on, stabilized approach. What's the most stabilized approach on any airplane in the world? An airliner on a coupled instrument approach. You're right on speed, you're right on glide path. It's really hard to screw up. And that's what I'm talking about here in these mountain airports. Do not, as even the late Sparky Emerson says, don't do this 1.15. And look at those videos of the airplanes up in Alaska landing real short where they drop it on. And that's absolutely the wrong thing to do. So I see some of my students here. Is there ever a reason to land on the end of the runway? Is there really ever a reason to land on the end of a runway? Only if you want to leave the airplane. Okay? Because takeoff distances are always longer than landing distances, right? Except one time. I fly full planes out of Alaska, and FedEx gave the University of Alaska Anchorage a 727. And they're at Merrill Field, which is a 4,500-foot strip. It was quite the event because they took everything off that 727 and put it right on the end of the runway there. But it was quite the event. But they were going to leave the airplane, so they put it on the end of the runway. And, you know, I teach this stuff, even I don't teach private anymore. But if you got a VASI, why don't you want to use it? Can you give me a reason not to use it? Because I don't know one, okay? Stabilized power on approach, even in these mountain airports. And what speed you want to fly at the book speed, right? Unfortunately, in little airplanes, we don't adjust for weight much, but when you got 1.3 over the stall speed, and you add half the gust factor, what was that thing in the beginning? Margin. I've got some margin, right? If I'm trying to land down the runway, even if there's no VASI, I'm going to look at that point I want to touch down, the touchdown zone, and I'm going to pitch to hold that glide path, and my hand is on that throttle because I really want to control that airspeed. Controlling that airspeed is really key because if you go fast, you're going to eat up a lot of runway. I forgot what the numbers were. I used to fly Learjets in the old days, and they used to say 3 or 4 knots is 1,000 feet of runway. Control that airspeed, control that glide path, okay? Obviously, pitch and power goes together, but don't be afraid to go around, right? Don't be afraid. American Airlines flight manual, a go around a successful maneuver, right? It is. We make more money that way, too, because we get paid. Anyway, next one. Canyons. Sparky Emerson's dwelling. Flying up canyons is really a dangerous stuff. Some rules, okay? You always want to have enough altitude so you can do a 180 and lose altitude. You may lose altitude in that 180-degree turn. You want to have enough altitude to lose that, okay? And remember your turn radius. I think we got a next one. Isn't there a next slide, please? Okay. Okay, there's a better slide. But anyway, everybody will obviously want to be able to clear the highest obstacle, but make sure that you can turn around and still lose altitude. Next one. I'm missing my slide on the next one. Maybe we can find it. There it is. Okay. Turn radius in a canyon. And you'll see all kind of mountain flying stuff about, hey, I'll do that 60-degree bank, slow it down, yank the flaps down. You always want to plan so you don't get into that kind of a situation. But if you do, remember higher airspeeds, and it says true airspeeds, but what are we really talking about? Ground speed, how fast are you going over the ground? And that turn radius at 100 knots in a 172, 182 at a 45-degree bank is 900 feet. That's a radius. So how wide does that thing have to be? 1,800 feet. Serious business in canyons. Very serious business. So annoying. Sparky talks about it as the point of no return. If you can't pull the power, if you can't turn around, pull the power back and still not crash, which is, I think, pretty good stuff. Pretty good stuff. All right, next one. Okay, I'm going to do this quick. I have a very long presentation on survival, but I'm just going to give you a short shot on it. What you have on your body may be all you get, okay? Now, we're talking about summer flying here. I do a big winter flying presentation, and that's a different deal. But I always have a serrated knife on my belt. Why is that? Cut yourself out of seatbelt. I fly a lot of float planes up in Alaska. We were out on, I wasn't there, my buddy was out there. This Cub flipped out about maybe 100 meters off the shore, flipped over. People were there with boats. They jumped into boats. The Cub flipped over. He couldn't get out of the seatbelt. Down he went. It's also a great survival tool. I have a coat that's a synthetic insulated Gore-Tex coat. It's either on me or right next to me. And if I get out with that coat, I'm going to make it, because the survival situation around here is maybe 2 or 3 days, right? So what's in that coat? I got a compass that's got a mirror on it. I got a whistle. I've got a little Sawyer water filter with a bag for it. And most importantly, I have what? My personal locator beacon, or my InReach SE. I don't know anybody that flies in Alaska without an InReach SE. And InReach SE, it's a satellite communicator, okay? It works off the Iridium satellite. Now, there's a personal locator beacon, which is even deadlier as far as guaranteed you're going to get there. But when you punch that emergency locator beacon, works the same 405 as your ELT, but that's 911. Whereas if you go down, you hit your InReach, you can text back and forth. Hey, I'm down, I'm okay, or I am hurt, or, say you're down on the Nushagak fishing and the weather gets bad. So you text back to your girlfriend or your wife and you say, hey, the weather's bad, I can't get home. And she texts back, you lying turkey, the fishing is good. So, but anyway, I can't recommend that stronger. And I know most people I've dealt with around here now have their InReach with them. So if you get out of that airplane with a warm coat with a hood, you're InReach, and I really am hesitant to say the next thing. I also have fire starter stuff, right? I have a Bic lighter and some of those really good weather matches and a little cube of wet fire. Be real careful starting a fire in these mountains. That's the last thing you want to do, right? The last thing you want to do, because they put you in jail for starting the fire and take all your money, okay? Anyway, so are there any questions? Huh? Next one. That's what we just talked about, okay? There's several of these things. There's a Spot, the Spider Track. They're all good. I used to have a satellite phone, $700 a year. And they don't let you roll the minutes over. The InReach is about a $400 item, $12 a month. You can text 12 times. You have a number of pre-selected methods. I don't have stock in them, by the way. Okay. Next one. I think that's it. Where's the question 3, Larry? Okay, next one. Oh, we got some nice pictures here. I always like pictures. These are airplanes that didn't follow the rules. Now, where do you think that airplane's going? Looks like it's trying to trying to outclimb that mountain there, right? Next one. There's a couple more of these. Oh yeah, nice. Do you think maybe he hit something there on the way down? Yeah. Does that parachute always work? I'm not a Cirrus guy, but from what I understand, to pull you got to be totally stable at a certain airspeed to pull it. You can't be going down. Yeah, and you have to be at a certain altitude, obviously. Nice stuff, huh? Oh, another guy. Look at the mountains terrain he was flying in. You got to trust your motor when you're flying in this stuff because. Next one. Ooh, boy. Bad stuff in the mountains. It's not like going down and, going out in the desert by Lovelock. That's when I used to do private stuff and I do the their night flying. I took that. I went out there, nice flat desert there as opposed to. You go down in the mountains at night, have a nice day, right? Have a nice day. Proficiency and peace of mind, and I guess here I'm saying practice, 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 okay? Take a check ride. I give myself a check ride. I mean, I got many, many thousands of hours. I do 2 or 3 instrument approaches every month just to stay sharp. Because as you get older, you're not quite as quick as you used to be, right? But repetition, repetition, repetition. Next one. Take a mountain flying course. We have one here, okay? We got a really good little scenario. We go into South Lake, we go into Markleyville, and go over all these performance. Calculate the performance numbers on your particular airplane. And, I take them up to South Shore and fly them over where that 172 took off to the south. Why isn't there any airline service into South Lake Tahoe? Yeah, it didn't work out very well. Why? Airliners got to be able to take off on one engine and climb over all the obstacles. Unless you're in an F-15, you can't do that going south. North you can. You got 22 miles of flat, right? Okay, good. Practice, practice, practice. I guess lawyers and doctors do that. They practice. Well, pilots do that too. The airlines, we take a check ride in 6 or 9 months. That's why airlines are so safe. So safe. All right. There must be a question here somewhere. I'm looking for the third question. Oh, the next presentation. See how stupid I am? Any other questions? Yes, sir. Right, McCall, Idaho, mountain flying course. You took one? Well, okay. You can do up to a 60-degree turn. And that's what those guys teach. Okay? That's interesting. Remember a couple of other things. When you're making a turn in a canyon, what is your reference? Does that canyon flat? Or is it, you can easily get spatially disoriented turning that way. And I like to say, don't do more than a 45-degree turn. Slow down as much as you can. And I know some of those mountain flying classes teach that, okay? But I'm sort of looking to guys that are not going to get themselves in trouble. Try not to give yourself margin, and don't do it. Don't do it. Yeah, there's, Shondell, all the things we teach, and those are all interesting. Shondell's not only done at what bank is a Shondell done at? 30 degrees. Yeah. Yeah, that's what you teach in the Airman Certification Standards. Okay. Okay, I'm done. I give up.
Thanks, Rick. Appreciate that. So, I mentioned to you earlier that there was going to be another event tonight that you're unaware of, probably. And it's really, it's the event that I really enjoy doing the most in my job. I don't get to do it as frequently as I'd like, although it is very enjoyable. And just in building it up is really worthwhile to me personally. That's why I put my coat on for this one. So I want to tell you a little bit about what it is. I'm going to award a Master Pilot Award tonight. The FAA is, actually. A Master Pilot Award. Has anybody in here not heard of that? Oh, a few people. Yeah, good. Let me tell you a little bit about it. To be a recipient of the Master Pilot Award, you have had to have flown an airplane for 50 plus years from the date of your solo. So that's pretty lengthy flying to get in those aircraft and take the risk and the hazards and the fun and the excitement every day and still be here to receive this award. It's called the Wright Brothers Master Pilot Award. And it's an award that requires not just 50 years of flying, but you can't have any kind of revocation action against your pilot certificate. It takes 3 recommendations from your pilot peers to recommend you for it. And it's one that is, once you receive it, your name gets put on a roll of honor for everybody ever and ever to look you up and see where it was issued to you. Well, tonight we have a recipient in our audience. If you'll go to the next slide. Next slide. All right, Fred, I'd like for you to come up here. Fred Lazor, people. Fred Lazor. Good job. Let me tell you a little bit about Fred. Fred had his first solo on 14 November 1970 in a PA 140 in Lucenza, Malani, Africa. I guess I said that right. Malawi. Okay. This is the most prestigious award that the FAA recognizes and honors for people for. As I mentioned, it's 50 years, 3 letters of recommendation, no certificate action for revocation or anything like that. Fred got his private pilot license in actually Tanzania in 1972. Did I see that one right? Yep. Okay, man, I'm learning. And his commercial certificate in 2020. He's flown nearly 4,000 flight hours in his aviation career. He's a glider CFI, and he received that certificate in 2001. Also, of that 4,000 hours, 2,200 of them have been in gliders. That's without a motor.
Best way to do it.
Yeah, and he's still here to get this 50-year award, man. Fantastic for that. Fred, it's my honor to present to you this Wright Brothers Master Pilot Award certificate signed by the FAA administrator, Steve Dixon, at the time. And, along with this award, we present to him a full blue ribbon certified copy of every record that we have of him in Oklahoma City. I could get this award very quickly, which I did, but that blue ribbon package coming out of Airman's Records, it drags along. But I will make sure you get that, Fred.
Thank you very much.
Would you like to say a few things, please?
If you want to do this, just keep flying. That's what I did. Yes, keep flying safely without any actions taken against you. This has been a great place to fly, Minden. Malawi was a good place to start. Minden's been a great place to fly gliders, as those of you who fly gliders know, and partially because of what we just learned about earlier, the mountain wave. I have been up in a glider for over 12 hours in mountain wave, and that's the kind of thing we can do. We've been up to 27,000 feet in a glider too. So thank you, Larry. I really appreciate this.
and I'll hang it prominently on my wall.
Well, good, Fred. And if you haven't noticed, he's wearing the Civil Air Patrol shirt. Been very active in that, very active in the Minden-Carson aviation community for many, many years here. Unfortunately, he's going to move, and we're going to miss him. But thanks a lot, and congratulations. Congratulations. All right, our next subject, special use airspace. And, you know, that's one that we don't really see a whole lot about, but we think that you can get in a lot of trouble with it, that's for sure. Several different categories of it, and my aviation safety representative that's provided so much support for me here throughout the years is Russell Smith, and he's going to be speaking to you on that subject. Welcome, Russ.
This is a pretty tough act to follow here. We got that great weather presentation, great mountain presentation, and Fred, what a great honor it is to honor you tonight. I had a lesson from Fred back in 2001. I was going to get my glider license in a week. You know, it was one of those things, and I flew out here. And Tony Sabino was running the operation at the time, and that's when I first met him. And I will tell one quick Fred story. I was out in the squadron building where it was a cadet evening, and Fred was coming back from a flight. He came in and he flew over, did a wing over, came around, landed, and taxied right up to his parking place and stopped. It was beautiful. It was right at sunset. It was a gorgeous evening, and it was pure beauty, sheer beauty. So I get to talk to you about special use airspace, and we're doing this because we've got some people that have gotten into trouble. So I hope I'm talking okay on this. It's far enough away. We got the good sign there. And this is the special use airspace. Now, acronyms are a big deal in the FAA. And so this is SUA, not small s, UAS, which is small unmanned area systems, right? This is prohibited, restricted, all of that's on there. We're going to cover that tonight, and I'm going to do one thing, a couple things. I'm going to give you 3 things you can do to keep from getting in trouble. We're going to talk what happens if you do get in trouble. We're going to talk about some misconceptions on special use airspace that happen, and we're going to give you a couple of other terminologies. There's a thing called technological bias that we need to address because this week we had it happen. And it's really sad when we trust our iPad and it's wrong. Quick show of hands. How many people have one of these? How many people have one that's current? Okay. They used to be every 6 months, didn't they? Now they're every 56 days. Okay. Yeah. So, but there's special use airspaces on here, and it's also on the iPad. On this particular plan that I've got, there's 35 layers that you can put in there for your iPad for flight. And there's a lot more on there, and I don't understand most of them. But 35 layers, and if you put all 35 on there, it can get confusing. So we're going to talk about that. Next slide. So this is we're famous. This is what it's like to fly here, right? Restricted. We've got them all over the place. Restricted area, and it's on the chart tab. You can look at that. These are sometimes, you can go through them. You can go from Minden to Salt Lake City and go almost direct to Bonneville if all the restricted areas are cold. But if they're not, you can't get through. And it tells you here how to check it and make sure that it is cold. And you've got to trust in that briefing and trust your iPad if you've got it set right. Okay? But there's altitude restrictions. This is a good slide because it talks about low and high. And restricted is the very can be very busy, a lot of military activity, and it lists there. Go ahead, next slide. So prohibited, we always think of the, Camp David, Washington, D.C., but there's other prohibited areas. And this one here, they're showing the Boundary Waters Canoe Wilderness Area in Minnesota. And that's a prohibited area. Now the next slide will show you there's some dimensions to it, till 4,000 feet, right? So, but what do we have? There's no communications. It's there. Don't fly in it. Usually in a restricted area, you've got a communications tab where you can talk. And we're going to talk about this when we get to MOAs, especially the new MOAs we have just south of us. So next slide, please. Alert areas. I want to talk about this as it relates to us around here. But you can see this is Miami and concentrated flight training. They've got these down in Arizona too, where the flight schools are. And there's just all kinds of activity going on. Lots and lots of training, lots of concentrated effort. And if you look, we have areas that we have altitudes, we have places we can call for traffic, and they're numbered. Here, I like to think of that area between Carson City and Silver Springs as a alert area. And we all listen to 122.9 in there, right? And everybody, it's really cool because people will say, I'm south of Highway 50 or I'm north of Highway 50. You just give off your altitude, you give off where you're at, and it's a way of keeping our traffic separate. Down in Washoe Valley, sometimes there's a lot of people there. South of Minden, north of Reno, there's other concentrated areas. Stay on that frequency. Make a position report about every 10 minutes. That will help. Next. Warning areas. Now this applies to offshore, right? What is a warning area though? Is it like prohibited or is it more like restricted? More like a MOA? Yeah. Okay, there can be activity out there. And again, this lists it continuous, unlimited, Jackson Center, okay? You can call and get help or get advice or get traffic. Next slide. We've got a couple new ones in our area, but an MOA. And this gets into the similar activities as to a restricted area. They exist and they separate military training activities from IFR traffic, which is normally routed outside of MOA. VFR traffic is permitted, but extreme caution should be used. Okay, I'm going to admit to making a mistake. I've already got my award, so it doesn't count. I was coming back with somebody who's in the room from Cessna. We had a new airplane, and we're flying back. And it's long slide from Kansas to Minden. Yeah, that's our wing commander back there. Yeah, ma'am, it's a lessons learned. Lessons learned, safety learned. And what happened was, let's take a shortcut, and we'll go through the MOA. It can't be busy. We'll go through the MOA, and we'll just go right into Minden instead of going all the way around. And we're looking out there, and we see something going on out there in the restricted area. So we called up, and it was turn left heading 190 immediately. Okay, I did immediately. I didn't argue. We talked about it. It's like we should have called. I should have called. I was PIC at that time and checked. They had a lot of activity going on, and we were in the way. And it happens. And we've got the new area south of Minden now, the Walker Low and Walker High, and it goes active next week, and there's going to be a lot of activity down there. So always call. Don't trust the fact that you don't need, your traffic is permitted, but extreme caution, call. Next slide. Oh, question number 3 for the YouTubers. There it is. There's the answer. Next slide. So the MOAs, they can be the They're described in the chart tab on our old-fashioned charts. There's altitudes, there's days, there's times. That can be very helpful. But still, if you're doing flight following, you're going to be safe. Next one. Times are inconsistent, yes. Sometimes they won't even list them. Now, here's the thing. When it's not active, you're talking to the center. Walker, you're going to be talking to Oakland Center. But if it's active, there'll be a military controller on the frequency, and they're dealing with it. So it's really interesting when it changes, like the thing that happened to us. That wasn't Salt Lake Center. It was a Navy controller, a range controller. So go ahead, next slide. Okay, so around here might be Oakland Center. That's the controller. And if it's not busy, they'll clear you through, no problem, they'll tell you. Okay, go ahead, next slide. This one. There's a great video, and we can't play it tonight, but it shows the cockpit, and it's the guy's in a fighter, and he's coming along like this. Think of it, look just like this. If you see this video, you can go to AOPA and play this on their special use airspace video. And imagine you're flying along, and all of a sudden, whoosh, just that quick, an airplane went in front of the jet. And it filled his windscreen. It was so scary. And if you watch that as a pilot, you're going to just go. And they don't have the voice. But the voice on the original one was, "We're going home." And he just peeled back, and, it was such a shock. This can be in an open area. These can be low altitude, and they can be very fast. There's no speed limit here. They can be flying at 250 knots. So there's a recommendation here. So we look at these. 3 numbers indicates routes are flown 1,500 feet above the ground. 4 numbers, they're flown at 1,500 feet above the ground and below. We're going to be going out checking the routes west or east of Fallon starting in May. We go out and we check for obstructions for the military. Go ahead, next slide. Yeah. No, they don't have ADSB. The drones that are in the MOAs, they don't have ADSB. No, they don't want the enemy being able to track them and find them. So they're not there. And you're going to see another slide coming up that talks about it. This is a good idea when you see these. Try and cross them at 90 degrees so you're not close, okay? It's really scary to watch that video. Next shot. So there's several pieces that go with this slide. It's lights out operations are used. Next week when we're doing this, there's no ADSB. There's mixed traffic. There's drones. There's Ospreys, there's helicopters. It's a real mixed bag. And lights out operations are authorized. So can you imagine trying to deal with that and not being able to see it? And then it's at night besides. We're not doing anything at night, by the way. But that can happen. Quick story. I was coming home one night, and I live down a slope. And I was turning eastbound, and I was looking east. This is just off 395. And I'm watching to the east, and I see this white light, very bright, very, very bright. And I see white lights coming out of it, like spitting fire. And I looked at it. Well, my neighbor saw it. And he came running over. "Did you see the UFO? Did you see the UFO?" And I'm going, well, it's not a UFO. I don't know what it was. I don't know what it was doing, but we all know it was in that restricted airspace, and we all knew it had something to do with weapons delivery. Just amazing, some of the stuff that goes on in those restricted areas. So, lights out operation, doing their thing, stay away, okay? Next slide. Controlled firing areas, one quick story. There used to be one that was charted as a restricted area down by Hawthorne, little round one. story. Mike Wojak, who many of you might know, he's a flight instructor. He was our state director. Talks about the time he was flying. He was a good 6 or 7 miles away from it. He saw a smoke plume go up, and he thought, wow, that was interesting. And in just a few seconds later, he was rolling 90 degrees like that. Just the concussion of that happening. I thought that was a pretty interesting story. It made me fly farther away when it was there. Controlled firing areas. They're supposed to stop if they see an aircraft. Okay, that's the rule that they have. Go ahead, next slide. They're not charted, by the way. Doesn't affect us so much here because it affects our border all around the contiguous United States. You need a flight plan. You've got to have a two-way radio and transponder, and registration number is 12 inches tall, and you can't travel internationally with a pink slip or a temporary aircraft registration. We're supposed to cover this slide. It's kind of required. We don't want people getting in trouble. Next slide, please. This is the one that gets a lot of people in trouble. And they're temporary flight restriction areas, except sometimes they're permanent. The one we have closest to us is at Beale Air Force Base. It's got a TFR, it's permanent. You can call and get clearance through it. But they want to be able to keep people away if they have to launch off, Global Hawk or something like that in an emergency. So Disney, because of the large number of people. Another time we get TFRs is where do we get one in Reno? Air races, also the stadium, right? 30,000 people, and it's a 3-mile radius, 3,000 feet, 30,000 people. That's a way to remember. And it's now, if you're talking to ATC, it's okay that you penetrate that area. So if the tower says straight out departure is approved and you're talking to ATC, you're okay. But if you're not, that's a problem. And we don't want you to get in trouble. Remember, at the beginning of this, I said we're going to give you a couple of things to talk about, keep you out of trouble. And that's one of them, is to plan. So we've got an election year this year. And you know how they go out and they work their party, and we're going to have VIP flights in and out of various areas. So be careful, because Larry tells me, not from experience, I hope, that when it's a presidential TFR, and if you bust that, it's a whole different animal. You're not dealing with the FAA. And Rick's friend down in Sacramento, okay, took off. He washed his airplane. He took off and flew around the pattern with it. It was only, how many miles was inside the TFR? 1 mile inside the TFR. He just took off and went around, and when he landed, the Secret Service was waiting for him. And that's a 90-day suspension, folks. So if they come to Reno to visit, or they come to do their campaigning, be aware. And if you don't have your iPad set up for TFRs, I check, and I'm going to be honest with you, I go out and we walk around, we call it a safety check in the flying club, and I ask, did you check the weather? Did you check NOTAMs? Did you check for TFRs? And sometimes I get that look, and I do it real friendly like. It's not going to, I can't do any enforcement or anything. It's not it. The point is I'm trying to educate. But you'd be surprised how many people forget to check NOTAMs and TFRs. They're out there, and they can pop up at a moment's notice. So the forest fire ones are the ones we got to worry about here. The TFRs for campaigning, the TFRs for sports, and there are some for the rocket launches that happen. And there's a rocket launch facility out at the dry lake bed. And they go over 10,000 feet on some of those launches. We've got to be careful. Mark's raising his hand. Yeah, that's right. That's a NOTAM. You're correct. But it's a NOTAM. Yep. You should be checking NOTAMs as well as TFRs. That's correct. I want to make that clear, but Yes, they do. And they do have a radio, and they do listen, and they pay attention. So they'll call, and we'll watch. But I just want to make it clear that you can get in trouble at a TFR. And a NOTAM, notices to aeronautical, it's important that you pay attention to those. Runway closures, it happens. Carson had the runway closed, and people didn't check the NOTAMs. They're coming in to land, and there's the white X, and what's that doing here? It was NOTAM closed. It's kind of embarrassing when it happens. So NOTAMs are important. Pay attention. Next slide. Okay, this is where we get into technological bias. If you don't have the right layers, remember, onions have layers, right? Shrek, onions have layers. Your iPad has layers. You need to have it programmed properly. You need to have a current sectional chart. Yeah, you can use this. This is a substitute. What happens when the batteries die or we lose a signal and you're out there far away from home and you don't have one of these? I do keep a current sectional with me at all times. I always have. But the data that you get is only as good, and if you're under 40, you don't understand this next term, but we were taught in the 80s, GIGO, garbage in, garbage out. I see the older people are all going, yeah, that's right, garbage in, garbage out. If you don't have your stuff set up right, you can get in trouble. So I want to caution you, we had an incident this week where we think somebody got into trouble, and it was because they were following their iPad and it gave them wrong information, and they went off the road and they got pretty far out in the desert and had problems. And it was only after one of our crew members talked to somebody else and we found out somebody else had that same problem. It happens in that area down near Dyer. So it's where two charts come together, and there seems to be some kind of a problem there that people get lost. It's just like the Bermuda Triangle of aviation or something. I just want to mention it because now it's happened. It happened to me once on a trip out east. I was using a navigator in a rental car, and we put in where we were going to go, and it took me to a cow pasture. And it was supposed to be a restaurant. And of course, you can imagine the argument with my son and my daughter-in-law and my wife, and who did this and what. Anyway, I went to a gas station and got directions. But it's important that all these components work. But my point to you is, what's your backup plan if it doesn't? What happens if your batteries go dead or your iPad overheats? You've got to have a couple redundant systems. I'm going to try and wrap this up really quick. Do I have another slide? No. So the end of this story is, I told you at the beginning I was going to give you a few pointers on what you need to do. Number one, plan. Plan what you're going to do. And granted, you're going to go out and do 3 takeoffs and landings at the airport. You're still going to check the weather. You still should check to make sure there's nothing pending. I wanted to thank Dawn, because we've got in our area now, we get an alert for the wind shear. And isn't that nice to get that wind shear alert in our TAF? We get that now. And that's been just fairly recently, in the last year or two, that we've gotten that. And I don't do instruction when we've got the wind shear alert. There's no sense in having it. It's 2,000 feet usually within the surface, and there's a huge differential. And I've seen some really bad things happen. So that's one of the things. So plan. Make sure you get your weather and check the NOTAMs and check for TFRs. And finally, have a backup besides the plan of what you're going to use for navigation and what you're going to do if things go wrong. What are you going to do if they close off? What are you going to do when the smoke comes in the summer? You're going to have the visibility down to 2 miles, and what are you going to do? Where else can you go? Where can you be safe? So that's a quick and dirty on this whole review. I covered the major points that I wanted to say. Make sure, remember your sectional chart's 56 days old. It could be some new stuff out there. Okay? Larry, anything else that needs to be covered? Anybody got any questions about special use airspace? Remember, drones are 400 feet below. We've had problems with drones flying into the airspace, coming in close encounters of the worst kind. It happens. Okay? Yes, sir. Yes, sir.
I've read somewhere that the FAA is trying to clean up the NOTAMs.
You were reading it correctly.
And because I was out in that area you're talking about between Carson and Silver Spring,
Yes.
and on 122.9, some official sounding voice came up telling the aircraft that is next to some lake or some river, you need to read the NOTAM.
Yes, that's probably the one for the rocket.
He was on the south side and on the north side.
Yes.
And he said south side. I know when he came back, I tried to find a NOTAM that he was talking about. And I gave up after 30 minutes.
You're not the only one. They did a complete overhaul just recently, and they're still doing it on the NOTAMs. This all started because I don't know how many of you remember the Air Canada jet that was going into San Francisco and was lined up with a taxiway with several airliners on it. And the NOTAM for that crew was on the 7th page of their briefing sheet that's 10 pages long. And it came out of Nav Canada, and I'm looking at Eric because he knew about it, and one of his friends was in the taxi line where there was 47 feet between that jet and four. Yes, thank heavens. Hey, what are you doing? So, but the NOTAMs, when they got into looking at them, the FAA found out that some of the codes are from the 50s when they did the teletype. And they still had some of those codes, and they're trying to build computer language to change all that. So that's why the NOTAMs are all changing and getting modernized and updated. And you can go to a website and hit NOTAMs. And on a lot of your software packages, you can hit the NOTAM button, and they're accurate. Much better, much better. But that one isn't tied to an airport, so that's what makes that one out there on Silver Springs a little different.
Russ, I was wondering that if they use the same spot out there in Silver Springs, why don't they request a chart change and show it to be a spaceport or whatever the heck you want to call it?
Well, because it doesn't go high enough to be a spaceport, but you're right. It's like we want to get a little parachute symbol for Minden. Frank, can we?
What is it, Minden 25 or whatever it is that we've got 4 miles off the end of the runway at Carson City, and that's for model airplanes.
Yes.
Call that an airport. If they can do that, call that an airport. Put something like that on in Silver Springs.
They could make something, but can we get a parachute symbol?
I'll have to look into what the requirements are, but I'll look into it.
Thank you. That was a question asked to me earlier. I said, please ask somebody at the meeting tonight. So that's all I got. It's been late, and we appreciate all of you coming. I hope we covered special use airspace and being careful and planning and plotting and making sure you've got accurate information. Larry?
Well, thank you, Don, Russ, and Rick, very much for tonight. Only one thing I might want to add as summer's coming, if there's a fire, there's probably a TFR. That's where most of our violations occurred last year. A lot of them were drones. Thank you again for coming tonight, and thank you, Frank, the Carson Valley Inn, and the Minden-Tahoe Airport for sponsoring us tonight. Thank you. Good night.
My last quick pitch I forgot. I left back there what to do in case you're intercepted. If you make a mistake, I told you if you make a mistake and all of a sudden you find that you're in trouble. Has anybody in here been intercepted? Please, let's see a hand. Thank you. She was with me. We got intercepted. It was a training mission for the Air Force. It's really something to see an F-15 with armament on it pull up next to you, flaps out, wheel down, and it's like, well, we went too close. And what you don't see is the guy behind you. Okay? It was a simulation. So in your Airman's Information Manual, Aeronautical Information Manual, there's what to do. All you got to remember is to dial in 121.5 and talk to the guys if you get in trouble. Okay? And it may happen if it's a presidential one with a helicopter that pulls up to you. So think about that, read about it, and have a good day.